All right, so I'm looking at the example that's given right at the top of 3.3. All right, SAS Triangle Congruence. All right, and we just finished looking at angle side angle and angle angle side triangle congruence, meaning that you could use the angle side angle postulate or the angle angle side postulate to say, I know those two triangles are congruent because I have just enough information to conclude that that particular angle or that particular side must be a particular length or measurement for the angle. Cool. So jumping into side angle side, we have two triangles here right at the top of our page here, and the first one, GHI, all right, has a length of 6 for side GI. It also has a length of 12 for side GH, and you can see that angle G has a 116 degree measurement. Let's see if we can find corresponding angles and sides in the next one, DEF. Cool. 12, 116, 6. That sounds like it probably should map pretty well, right? So let's try to see if we can figure out, just looking at those angles, what information we have and if we can find the corresponding angles. Angle I, all right, we don't know that one, or H, but we do know G, that's 116, and we do know that D is 116. So we can then conclude that if G and D are corresponding angles, let's take a look and see how this particular triangle might map onto between the two of them. All right, so the rigid transformation example is not fantastic on this page, so we'll probably do one of those in class. However, imagine you're just reflecting and then rotating it so that it would fit right onto, GHI fits right onto DEF. The question is, will it? If I rotate and reflect, we'll see that like the 12 side should match up, and the 6 side matches up because they both have 116 degrees in the middle of them. And so you can see that if I have the side and an angle and another side all, adjacent to one another, I can conclude if two triangles have identical numbers in those particular in that particular situation, side angle side, that these two triangles must be congruent. All right, that's the basic idea. Now, if I only had 6 and 116 degrees, all right, this could be this could be like a lot of different lengths, right? So this length could be 14, all right, and that would make this length a whole lot longer as well, all right. So that's the basic idea. You can't do it from just an angle and a side. You can't do it from just an angle and another side, right? It won't work like that, even if they look like they're congruent, all right? In the SATs or on the SATs, they often will give you two figures. Imagine you have a figure that looks like this, but the numbers are a little bit different. You might look at this figure, these two figures, these two triangles, and say, yeah, of course they're congruent. Look at that. They got 116 degrees. That side's 6. Great. I'm moving on. Congruent. Done. Moving on. Well, no, you can't necessarily prove that unless you see enough information like an angle side angle that are adjacent, an angle angle side that are adjacent, or a side angle side that are adjacent. You can't necessarily draw the conclusion that the two triangles are congruent. All right, so I'm going to pause there. I hope that this was a helpful explanation for 3.3.